Hello, everyone. Welcome back. Today, we're going to be talking about finding the nth term of a geometric sequence, and we'll also go through three examples of this. So, first off, how can we do this? What's our general equation that we're going to use? Well, basically, to find the nth term, we need to first isolate with respect to a of n, right? And then we have A1, which is the first term. Also, sometimes this is known as T1, which just means term one or the first term that we start with. Then we have R, which is the common ratio. And then N is the term index. So, which number term are we looking for? Are we looking for the fifth term? Are we looking for the eighth term, the 10th term? Which term are we looking for? And that's going to depend on the question. So let's take a look at this example here. It says, write an equation for the nth term of the geometric sequence and find the eighth term. Okay, so first let's write an equation for the nth term. To find the nth term, it's going to be a of n is equal to a1, which is the first term. In this case, we can see the first term is 5, so that's good. Now, how do we find the common ratio? To find the common ratio, what we're going to do is we're going to take any term divided by last term. So 15 over 5 is equal to 3. Now notice, had I chosen different terms, had I chosen 45 and 15, 45 divided by 15 is also 3. 135 divided by 45 is also 3. So no matter which ones we choose, we'll always get the same common ratio, which is good because if we don't, that either means we've miscalculated or it means that the sequence we're looking at isn't actually a geometric sequence, because a key characteristic of every single geometric sequence out there is that there is a common ratio, one single common ratio. The ratio doesn't change throughout the sequence. Okay, so 5 times 3 to the power of n minus 1. So this is the equation for the nth term, right? We could plug in any n we wanted and figure out the term, right? I could plug in 1 here for n and we would get 5. If I plug in 2, I would get 15. If I plug in 3, I get 45, and so on. And they want to know what's the eighth term. So I'm going to plug in 8 for n and get 5 times 3 to the power of 8 minus 1 is equal to 5 times 3 to the power of 7. And then I'm going to grab my calculator and type that in. And this equation, it makes a lot of sense. It's going to be 10,935, which may seem pretty big. However, when we do have geometric sequences, they do get big very, very quickly. In this equation, it makes sense if we think about it. We're starting with 5, and then if you were wanting the eighth term, that means we multiply by the common ratio. We multiply by 3 7 more times to get to the eighth one, hence 3 to the power of 7, and then we get our answer in the end. And so in that way, this equation makes a lot of sense. Okay, let's do two other examples. Write an equation for the nth term of the geometric sequence and find the seventh term, a to the 7. Okay, so to do this, first I need to identify the first term, which is a1, and that's just going to be 4. And then I also need to identify the common ratio. And to do that, I just need to take any term and divide it by the previous term. I usually do this with the first two terms just because it's the easiest. So I'll do negative 8 divided by 4. But again, let's say we chose 16 divided by negative 8. We would still get negative 2. Or let's say we chose negative 32 divided by 16. We would still get negative 2, right? It is going to be the same regardless of the numbers you pick, as long as you make sure to pick consecutive numbers. So we can't just pick this one and this one. We have to pick numbers that are consecutive or that are right in a row, right, one after the other. Okay, so the answer is a to the n is equal to a1 times negative 2 to the power of n minus 1, like that. And then we need to find the seventh term. A7 is equal to 4 times negative 2, 7 minus 1, which is 4 times negative 2 to the power 6. And negative 2 to the power of 6 is equal to 64. And the answer to that is 256. So therefore, the seventh term in this sequence is 256. All right, let's try the last one. Write an equation for the nth term of the geometric sequence and find the ninth term. Okay, so for this one, our first term, a1, is equal to 1, and our ratio is 3, right? Notice if we do 3 divided by 1, we get 3, or 9 divided by 3 is 3, 27 divided by 9, it's 3. No matter which calculation we do, we get 3. So for the equation, it would be a of n equals to a1, which is 1, times 3 to the power of n minus 1, and that's just the same as 3 to the power n minus 1. So term 9 would be 3 to the power of 9 minus 1, which is 3 to the power of 8. And if I grab my calculator, 3 to the power 8 is 6,561. Therefore, the ninth term in this geometric sequence is 6,561.